Okay, so on this question, we have an equal sign. So let me put that in. I like to separate. So we have left side, right side, right? Okay, so what do you do when you have rationals, means fractions, with an equal sign? All right, step number one is you need to factor any denominators, right? Anytime we have denominators that are not factored, we need to factor them. And so that would be right here. See how that denominator can be factored there? So let's do that. This is going to be in here. I'll just do the other two. Minus sign in between here. And this is going to be 5 over x plus 1 over 2. This one is going to be take out a 3. See what happened there? Right? Because these guys both had a 3 in common. So we always need to factor that when that shows up, right? Anytime denominators have anything in common, we need to factor. All right, so factor denominators, check, did it. Step number 2. Now, we have an equal sign, right? We have an equal sign, which means we have a left side and a right side. So all of my thinking is left, right, not top, bottom. Are you seeing this difference? Because I have an equal sign, I have a left and a right. So all of my thinking is left, right. I'm not going to come in here and do like 3 on the top and the bottom and stuff like that. I'm not going to do that. I'm not thinking top, bottom. I'm thinking left, right. Why? Because I have an equal sign. With an equal sign, you have a left side and a right side, but you're equal. As long as you do the same thing to the left and the right, if they were equal before, they'll be equal afterwards, right? It's logical. So what am I going to do? Multiply all the terms left and right by the LCD over 1, the common denominator. Now, what is the LCD? How do you know what the LCD is? The least common denominator is every item in the denominator multiplied, or, let me put it this way. 1 of every denominator item. That's a good way to put it. 1 of every denominator item. So you look at all the denominators. You say, I'm going to take 1 of everything. Like you're going to the store shopping. Say, I'm going to buy 1 of everything at the store today. That's pretty much what we're doing. So I'm going to need an x plus 1. Oh, by the way, an x plus 1 is a package, right? Remember, pluses and minuses glue things together like shopping at Costco. That's a package. I need the 2, I need the 3, and I need the x plus 1. 1 of every denominator item multiplied together. Let me put it that way. Multiplied together. So I need 2, 3, and x plus 1. That is all that I'm. So what is that all together? That is, put it here for us, 6 x plus 1 over 1. Do a better job on that. Do you see where I got the 6? 2 times 3. Everybody see that? And then whatever you do there, you do to all the terms. So I can do it in the middle and over here. You can just put it in the top. You don't need to show the 1 in the bottom. I mean, it's okay, right? It's just, my point is it's in the top only, not the bottom. I'm not doing top and bottom. I'm doing left and right. It's okay to be, you might think, is it okay to mess with just the top and not the bottom? Yeah, because I have an equal sign. It wouldn't be okay if I didn't have an equal sign. But because I have an equal sign, I'm doing the same thing to the left that I do to the right. This making sense? See where I got the 6? Because I did 2 times 3 times x plus 1. The LCD over 1 is 2 times 3 times x plus 1. In other words, 6 times x plus 1 over x plus 1. So the common denominator is 1 of everything. 1 of every denominator piece. everything, one of everything. And then what do you do on the next step? Let me write in step 3 for you. Step 3, cross cancel. Cross cancel and multiply the leftovers. So whatever's left over, you multiply. So I'm going to go, okay, let me see, back here. I'm going to cross cancel x plus 1, x plus 1. What's left over? 6 times 5, 30, minus. What's going to happen? So far, so good. Am I going too fast? You see that? Let me slow down there for a minute. So I cross canceled the x plus 1s and the 6 and the leftovers multiply. Remember, the purpose of the common denominator is to take out all the denominators. Let's let him do his job. He's supposed to take out, because we don't want any more fractions, right? Fractions are a pain. We're trying to get rid of the fractions. And that's exactly what the common denominator does, is wipe out all the fractions. So the x plus 1s cancel. 6 times 5 is 30. What happens in the middle? 2 goes into 6 3 times, and we're left with 3, x plus 1, which I will multiply in a minute. Here, x plus 1 cancels x plus 1, and 3 goes into 6 2 times, and I've got 6 times 2. In fact, why don't I just bring this down more slowly? 6 times 5. I'll just make it 30 on the next line right here. The minus 3 will distribute. Minus 3x minus 3 over here, 12. Is this making sense what just happened? Let me back up, because the first 2 steps are the most important. After that, it's not too bad. So one more time. Step 1, factor denominator. So I factored this denominator, right? They had 3 in common. I took out the 3. Then step 2, the most important step, multiplied all the terms left and right by the LCD over. What's the common denominator? 1 of everything. Like, I'm going to the store today, I'm going to buy 1 of everything. That's what you're doing with common denominator. You look down underneath the bar, you look at all the denominators, you say, I'm taking 1 of all you guys. I'm taking an x plus 1 package, right? Plus and minuses glue things together. Taking a solo 2. I'm taking a 3. And I don't need that other x plus 1 because I'm just taking 1 of everything. So I take 2 times 3 times x plus 1, which is better known as 6x plus 1. Over 1, over 1, over 1. All the terms left and right. I'm doing the same thing to the left as I do to the right, aren't I? Same thing to the left that I do to the right. All the terms left and right, right? Because they're equal. The left side equals the right side. There's an equal sign here. The left side equals the right side. So as long as you treat them the same, if they were equal before, they'll be equal afterwards. And then what do? You cross cancel. See right here how I cancel? You know, top and bottom cancels, huh? That's the whole purpose. That's why we're doing this, because we want to get rid of all the denominators so we don't have to deal with fractions anymore. See how on the next line there's no more fractions? Why? Where'd they go? They all canceled out, right? Cancel and multiply what's left over. Cancel 2 into 6 3 times, multiply what's left over. Cancel x plus 1, 3 into 6 2 times, multiply what's left over. Then multiply them out. And now just solve. Just solve for x. So 30, take away 3, what's that, 27? Just use your calculator if you're rusty on some of these. I got an x is saying, I want to be alone. I want to be alone. Get rid of this stuff so I can be alone. It's like, oh, okay. So subtract 27 from both sides, right? Get rid of that right there, right? Because x is saying, I want to be alone. What do we get? Just use your calculator, minus 15. And what's always the last step to get x alone? You know, divide, huh? And remember, whenever we divide by the identical twin, same sign, same everything, don't we? Adding, subtracting, we always do the opposite sign. But dividing, we do the very same sign, don't we? Because why? Because 2 negatives. These 2 negatives here, they will cancel to be positive x, right? This and this will cancel. And over here, positive 5, right? 2 negatives multiply or divide to be positive, don't they? So there's our answer. X is positive 5. There we go.